We have seen in the past lectures that subspaces of Rn can be expressed in an efficient way using a couple of spanning vectors. Well, we will provide you with the instruments that express how you can do this efficiently. Well, first of all, consider vectors v1, v2 to vm in Rn, and we're looking at what we can create with these vectors using linear combinations. Now, first of all, we line up these vectors and using the index, and a vector v1 is called redundant if it's the zero vector. Yeah, so v1 does not really add something to the tuple as it is the zero vector, and we know that the zero vector leaves basically any calculations with vectors in unchanged, like summing, like scalar products. Well, a vector vi, so this is an inductive definition, so a vector vi in this set of vectors is called redundant if we can express it as linear combinations of the vectors v1, v2 until vi minus 1. So if we can express it as a linear combination of the vectors preceding the vector vi in the sequence v1 till vm. Now, we will call the set v1 to vm linear independent if none of these vectors is redundant. So no of these vectors can be expressed as a linear combination of former members in this series. So if none of these vectors is redundant, and these vectors are called linear dependent otherwise. So if we can express one vector in terms of the other ones using linear combinations, then we will call this vector linear dependent on the other ones. So for example, we have three vectors here. Then we see immediately that v1 is not a zero vector, so v1 is not redundant. Yeah, so it's not a zero vector. If we look at all linear combinations of v1, v2, v3, we really need a v1. This is another way of saying that it's not redundant to consider the span. Well, v2 is not redundant either, since v2 is not the zero vector and it's not a linear combination of a v1 only. Yeah, so it's clearly not a constant times v1. Now v3 is in fact redundant, since v3 is 3 times a v1 plus v2. So if we look at v1, v2, v3, then these vectors are linear dependent.